Hello, so this is a revision video for AP Chemistry 8.4, Acid-Base Reactions and Buffers. When a strong acid is mixed with a strong base, they neutralize each other in a complete reaction. This is represented by the net ionic equation H plus OH goes to form H2O. The acid donates a proton H plus and the base provides a hydroxide ion OH forming water. A salt is also formed from the conjugate ions of the acid and base, but these ions are spectator ions and don't actually change during the reaction. When a weak acid reacts with a strong base, the reaction can be represented by the equation Ha plus OH goes to form A plus H2O. The reaction goes to completion and all the Ha, the weak acid, react with OH to form the A and H2O. If the weak acid is in excess, a buffer system forms. If, however, the strong base is in excess, then the pH of the solution will be determined from the concentration of excess OH ions left behind after the reaction is complete. If equal amounts of Ha and OH react, then the conjugate base ion A- will be left over. This will react slightly with water to form more hydroxide ions, increasing the pH slightly. So, a solution formed when a Ha and OH react perfectly together will actually have a pH slightly above 7 because the A- ions formed will react with water molecules, producing more hydroxide ions. If a weak base reacts with a strong acid, we'll also get a complete reaction. B plus H3O plus goes to form BH plus and H2O. Where B is the base, H3O plus comes from the strong acid reacting with the water, and BH plus is the conjugate acid formed from the base accepting a H plus ion. Again, if the weak base is in excess, a buffer system forms. If the strong acid is in excess, then the pH will be determined from the concentration of H3O plus ions left over at the end. If equal amounts of B and H3O plus react together, only BH plus in the solution remains and will ionize slightly to form H3O plus. In other words, BH plus will react with H2O to form B and H3O plus. So the solution won't be completely neutral and will have a pH slightly lower than 7. Assuming 298 Kelvin. If a weak acid and a weak base react together, the reaction doesn't go to completion. Instead, there is an equilibrium established, where Ha plus B is in equilibrium with A- and BH plus. The position of equilibrium and the final pH of the solution depends on the relative strengths of the acid and base. This can be determined from their Ka and Kb values. A buffer is a solution that resists changes in pH when small amounts of acid or base are added to it. Buffers work by having both a weak acid and its conjugate base, or a weak base and its conjugate acid. They are present in equilibrium.